Welcome back to Element 14 Presents. I'm Clem. Today we are celebrating our 500th episode with our Build Inside the Box 500 competition. Myself and two other hosts will compete to see who can build the coolest project with the parts inside this box.
That's right, Clem. Once our projects are complete, you can vote for your winner at the link in the description. The grand prize winner will get to donate a shopping cart worth $750 and electronics equipment bundle to the charity of their choice.
The other two runner-up projects will get to donate a $500 shopping cart and a slightly smaller equipment bundle. So no matter what, everybody wins.
I know what you're all thinking. What's inside the box? Let's find out.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
So my Build Inside the Box box has just arrived. So I'm going to open it up and have a look at what we're going to have to play with. Wonder what's inside.
Okay, some packaging stuff. And the first thing is an Arduino Maker Zero.
So I'm really excited about this. I've never actually had a go with one of these. I've only used Arduinos that have been AVR based.
Oh, I see what we've done. Okay. The thing that kind of threw me for a loop is that there are a whole bunch of loose pieces inside of the box. So this looks like an MCP 604.
And that's a operational amplifier, so a little op amp.
Then we have this thing here, which is a light barrier or a light gate.
And then there's a TO220 or TO92. So this is also an MCP, looks like 8701E. So we'll have to figure out what that is because I don't know the MCP part numbers offhand.
So we've got a temperature sensor. So that's going to be another input for our SIS project.
Okay, so there are two displays. I wasn't expecting that. All right, that's cool.
And according to the pinout, it says 5-volt supply on the back, so that's awesome.
This is a time of flight sensor from ST Microelectronics, which is really cool because I've been wanting to test these out for a while. You can use these for proximity detection or gesture detection, as well as a number of other things. So this will be interesting to see how these work.
Aha! So then we've got a large selection of Wago connectors. So I've used these quite a few times in the past. It looks like we've got two main packs with a selection in. We've got two different sizes in the packs. So we've got the smaller ones, which are up to 12 AWG, and the larger ones are up to 10. So we've got a 5, 3 and a 2 in each of those packets. So they'll be really handy for wiring everything up.
And then in here is a power brick or power bank, 10,000 milliamp hour, all right? 2 USB, 1 amp and 2 amp. I'm probably going to end up taking this apart because I want to find out what is the charge controller that it has, and maybe we'll just repurpose the batteries for something. I don't think the rules say that I have to use the parts as is. I think I can change them, which we might end up doing.
Hello.
Hey, how are you?
Hey. Hi. Okay, we've got a Katie, we've got... James, are you there?
I think I'm here.
Do you got your box and stuff?
So I think my emotions range from, okay, I know exactly what I can do with this, to what am I going to do with this? That seemed like the complete range.
So my thing is, we have the VL53L0X, that time of flight, I think it's a laser-based sensor. And so I thought about using it as some kind of 3D scanner.
I was going to say, would you do full revolution and then downer?
Yeah, like make 2 axes and does a full revolution, goes up one, full revolution, and then generate a point cloud and save that to the SD card.
So the project I have in mind is basically a POV display. If it was a single display, I'd be worried about the refresh time, but I think having 2 of them, I might be able to get it to refresh fast enough to create an interesting display. And then that also makes for a really good use of the photo interrupter.
Oh, so you mean you let them rotate at a high pace and use the photo interrupter to get the timing right?
Yep.
That could be really interesting.
All right, Katie.
But that's
So
a
what
good
what can you tell us about your project?
Well, I was trying to think. I'd had a couple thoughts. Last minute, just before this call, I was looking and thinking the Maker Zero, if you look on the page for it, makes a lot of stuff about audio and sound. And then I sprung into my head that the gesture sensor and that with audio sort of makes a musical instrument, sort of theremin based, fake theremin, but
That would be a really cool use of those time-of-flight sensors. I think what's going to be really interesting is now that we all have sort of a starting point, I'll be curious to see if we all stick to our original plans throughout the build.
I can guarantee you that something will change, because in every project something goes wrong. And so far it did go pretty good. So something is going to go horribly wrong.
How many projects end up at the same place as they were starting out at?
Yep.
Pretty much none for me.
All right, I'm going to take off. I'm looking forward to seeing what you guys build.
Thanks.
Yeah,
You
we'll
too.
see you lose. Goodbye.
I can't
See
wait
you
to beat
later.
you, Clem.
Okay, now that I know what the others think of the parts, I can maybe be a bit tactical. So Katie's build will probably be a lot of fun and will probably look pretty good, but James's build doesn't seem to be very practical. So maybe I can beat him at his own game by making a practical project. So I decided to use the time-of-flight sensor for scanning physical objects. Maybe I can build a 3D scanner. And I have like a fallback plan. So first I want to build a tiny 3D scanner that scans like mini objects, so I can contain that possibly inside the box. And then if that doesn't work, I can even fall back on something else. But I want to scan physical objects. That's the plan. Of course, I'm using the Arduino Maker Zero as the brains of the project and the SD card to log the data that I acquire. The sensor, the time-of-flight sensor, is connected via I2C. That's great. There's a ready-to-use library for that one. But I couldn't get the OLED to work. And it took, well, I have to admit, I had to ask Katie, and she sent me the link, because apparently, despite the markings that said serial clock and serial data on there, it's actually an SPI display, and I didn't know that, and now I got it working. Thanks, Katie. So I wired everything up on perf board for quite a while, and then I tried to get some basic readings out of the device with some test code, and it turned out that the sensor only gives me millimeter range. And I don't mean inside a millimeter, but it's as coarse as only millimeter increments. That's not good for a tiny 3D scanner. Okay, so that scanning idea doesn't really work. So my alternative plan is to scan the box itself. And I don't mean the barcode, I mean the physical dimensions of the box. Because there's a thing called Paketmarke or parcel stamp here, where you pay your fees depending on the size of the box and not about its weight. And that's cheaper to send lightweight packages. So I need to determine how big they are and how they compare to the tables on the website to find out which stamp I need. And usually that's measuring and calculating, and I don't like measuring and I don't like calculating, I just want to send stuff out. So I'm building a scanner that scans the size of a package and then tells you what postage you need for it.
After the phone call with Clem and Katie, I spent some time with all of the hardware pieces to decide what my final project would be. I told them it was going to be a POV display, but in reality, I was thinking about something else. And now that I've played around with the hardware, I think I can do it. I want to build a tricorder, like from Star Trek. Starting with the time of flight sensor or proximity sensor, I found that it could measure between 20 centimeters or about an inch, up to 1.5 meters or about 4 feet. At first, I thought a digital tape measure would be a perfect application for the tricorder. However, I got to thinking about it and I needed a way to determine when the flap was open or closed. So instead, I'm going to use the proximity sensor to detect when the flap opens up. The temperature sensor is pretty straightforward. I'm just going to connect it up and measure temperature. It's pretty easy to use. It outputs an analog voltage, so we just have to read it with an ADC input and we'll display it on one of the screens. For the photo interrupter, I did the most types of testing. At first, I thought about some kind of barcode scanner so that we could input data into the tricorder. I was able to build a paper-based mockup that worked really well for a handful of bits. So the other idea I had was to remove the daylight filter from the phototransistor and just use it as a general purpose light sensor. So basically I just broke the phototransistor apart and then I had to remove the daylight filter. And when I say remove the daylight filter, I mean just sanding it until the IR filter was gone. The next idea I explored is data transmission. I used 2 of these parts in order to transmit data between 2 Arduinos wirelessly. And this had some really good results. It wasn't until I got to some really ridiculous baud rates that it kind of fell apart. Now, I did think about using the op-amp to amplify the signals so that I could maybe get a little more distance out of them. However, I decided to abandon that idea and instead use the op-amp for sound. It occurred to me that the Arduino Maker Zero has a DAC output and it has an SD card. So I took a tricorder sound effect, made it a WAV file, and then I'm playing it through the DAC on the Maker Zero. It needs a buffer, so we're using the op-amp to drive a speaker. When I unboxed the parts and saw the battery pack, I immediately assumed I would be taking it apart, and I was right. Now, I was hoping the inside would be flat battery packs, but instead it's individual cells. So we are going to use one of the cells to power our tricorder. I just wish I could get something in a different form factor. I'm always a little bit nervous about using lithium polymer cells, and so I like the idea of using the Wago terminal blocks as a sort of quick disconnect if I need to pull the battery out of the unit very quickly. And so I'll place one terminal block on either side of the battery and connect through those. The processor in the Arduino Maker Zero is the SAMD21, and it has a ton of cool functionality. Now, I already mentioned the sound output. It also has a touch controller built in, which I'm going to use to make buttons on the flap controller. One reason to use the cap touch buttons is they don't take up a lot of space. But the other reason is obviously to make the project look cool. The OLEDs will just be displays. I'll use the capacitive touch buttons in order to change whatever's being displayed on them. I am going to add a third display just because I need a couple more lines for information about what's going on with the tricorder. We did talk about it as a team and we decided we could add anything we wanted to the project as long as it didn't take away from the parts that were already in it. And since I do need kind of a rectangular screen to make this work, I think it's fair to add. I was trying to make it as close to the prop as possible, but the prop's not functional and I'm limited because of the parts I have to use, like this stupid battery. So I have to get all this stuff to fit inside of this box, which means I'm gonna be busy.
So I'm still going with my idea from the brainstorming call. I'm gonna make a musical instrument type device. We've got plenty of sensors. I can use all those to change a tone that's coming out of it, change the frequency, to change the pitch. So yeah, I'm going to crack on and get started with that. To begin with, I've just put some sockets on the back of the range sensor so I can plug in to the Arduino, and I've just connected one up to the Arduino and connected in a pair of headphones. And now we've got sort of a noise here, but it's controlled, so the code is just looking at the height. It goes a bit out of range if you get too high. So I think I'm going to add in the code to stop at about 50 centimetres, just because then it seems to be getting a bit unreliable. My next thing I'm going to look at doing is I'm going to connect in this and get it to, I'm thinking, change pitch when it's closed. Let's connect that up. Now I've soldered up this strip board, I've put Wago connectors on the end of each line, so this means I can connect up all the sensors and screens and stuff really quickly and easily. So my painted box is now all dry, so I can fold this back up into box shape. So now let's fit the electronics inside of it.
Hey people, have you finished your things?
I am finished. How about you, Katie?
Yep, I'm finished too.
So I have a confession to make. When we did our last call, I might have lied to you guys. I had already decided not to do a POV display, and instead I decided to make something more like a tricorder, hence the red shirt.
I knew it. I know it! And that's why I also made a completely different thing.
And that's why. So what did you end up making, Clem?
No, the real reason is I learned that what I wanted to build is not really possible with that parts, or just in theory, but not practical. So I've made a different thing. The difference is I focus this time on real world applications, so it's actually useful, not just a decoration piece like your thing there.
Hey,
so I hope
wait a
people
minute.
honor that.
Wait a minute. So I want to be clear. My tricorder is not prop accurate. It is a functional tricorder. It can actually measure things.
Oh god.
All right, Katie, how about you? How did your project go?
So when we did our last call, I had two ideas and I was leaning towards one. So I've actually done what I said I was going to do.
Oh god.
And I've used the actual box.
Oh my god. I've also
Yeah.
incorporated the box. Different, but it's in there.
Yeah, I've done like a music player instrument thing that you can control with your hands.
Yeah, I was
Sorry.
really worried about your project, Katie, because that sounded like a really creative way to use the parts. My favorite part to use were the Wago screwless terminal adapters. I used them while I was like building the circuit. Like I found it was really easy to I had these bare wires, and instead of like soldering them together or whatever, just throw them in the terminal blocks and they're easy to go. And then in my final design, I actually am using one, and I just did it right before the call, is I'm using one to disconnect the battery from the circuit so that I can actually kind of use it as a quick disconnect, which I think compared to you, Clem, is probably a more traditional use for those parts.
Yeah, I thought so too, to use it as kind of a switch, but then I decided against it because I was like crunching on time. So yeah, that idea didn't get realized.
And then
But at least I used more. I think I earned some points for using more than one.
I used quite a lot in mine. I just connected everything with them. It's just
Why
like-
do you have to do it? Why do you have to be like that? Give me just one little victory before you take this thing.
sorry, that is too funny.
Okay, I don't think I can take any more. Let's roll the build clips and find out who's the winner.
Now that everything seems to be done, let's try it out. First I have to attach my device to wherever I want it to be. That's why the Wago connectors come in handy. I just put wires or screws in there and make them fit to any object, so I can visually place that wherever I want. I place my device under it after initializing it. On the initialization it measures how far the ground is away, and if I put the parcel there it knows the difference equally to that side of the parcel. Scan it 3 times. So I get all the dimensions, and then it tells me which postage stamp I need, and it's PM45. Great! So now I can send that parcel up to the next parcel. And I know it says next parcel. I call it this, it's the Spanish mode, okay? It's
I've taken everything in the box and I've turned it into a tricorder, or as I've been calling it, a bald quarter. I did add some LEDs so that we could get some nice fancy displays going on, but on the front panel there are ports for the 2 sensors. So the temperature sensor works about as expected. It does bounce around a little bit, but it did that during testing, so no big surprise there. The light sensor, however, is not as sensitive as it used to be, but it still does detect light. So I'm calling it a daylight sensor at this point. I'm really happy with the way that the sound effect came out. And of course, I really like using the capacitive touch buttons to control everything. By the way, I even added a couple modes on the OLEDs so that it would be a little more interesting to look at. There's a random pattern for the light sensor, and then the temperature sensor can have some debug information, which even by itself I think is pretty cool because it sort of reminds me of Star Trek with totally random numbers, even though they're not random because I know what they mean. Of course, the flap is fully functional because I'm using the time of flight sensor to see if the flap is open or closed. The whole thing is powered by a single cell from the USB power bank, which I connected to the Arduino Maker Zero using those Wago terminal blocks. So we've got the Arduino, which uses the SD card for the sound, the Wago terminal adapters, the power bank, the time of flight sensor, the temperature sensor, and then the photo interrupter, which I turned into a light sensor. So I think I was able to use everything that was in the box to make the ball quarter.
So I've put the software on it, so now let's power it up and take a look at it functioning. So after the assembly, the only slight changes I've made, I've added a power resistor here because the power bank was automatically switching off because the load on it wasn't high enough. So just putting that resistor there keeps it turned on. And unfortunately, my Arrowditing servo trick didn't work. The first time I moved it, it just shattered off. There's not really enough surface there for the contact. So the code all works, it moves the servo, but the servo won't move the potentiometer. So I've just moved it and stuck it upwards, and then I can show you the functionality by twisting the knob. But if I get another digital pot, that would all work fine. I'm going to power it up. Now, when I was checking things worked, I've been using these headphones, but so you can hear it as well, I'm going to plug in these speakers. This one does the change in frequency. I can put something in there and change the tone. Like I say, the temperature, if it was connected to the computer, you can see the change. So then I can change the volume. And if I don't have anything on the volume, it's just maximum volume. So if I hold that, I can... So that one sounds more subtle and faded with the softer edges. And this has the squarer edge, the sharper changes, with the sharper changes between the notes. So I'm really pleased with how it's come out. I think anyone would feel compelled to have a go. So it would be a really good piece to take somewhere, to a festival, to a gathering. I think everyone could have quite a lot of fun playing around with it. The only things I'd like to do before that is change the servo and potentiometer to a digital pot, like I'd said. I also think it would be really cool if the phototransistor, instead of you needing to put something through with your hand, if it was made into like a foot pedal and then you could do both hands and control the pitch at the same time. That would be quite cool. And another idea I had was you could use the SD card on the Arduino to log everything whilst you're playing. So you could log all the frequencies and the volume, and then you could play it back at another date. That might be quite cool. But as it stands, I really like it. I think it's come out really nicely. So that was fun, but which of us won?
I'm honestly not sure. That's for the community to decide.
That's exactly right, James. Hop on over to the Element 14 community at the link in the description and vote for your favorite project. By the way, also subscribe to our Twitch channel where James, Katie and I will discuss our builds next month in a live stream, and we'll also be announcing the winner. See you then! I gotta go, there's another project waiting for me.